sub. And so we are going to go ahead and do your lesson, even though I'm not there. You should have gotten a handout today for your notes that you guys are used to. It looks similar to this, if you can see it. All of the vocab on the top you're going to need to fill out from your book. So it is in section 2.1. And of course, I didn't write that down. 2.1 is probably on about page 58, 59, 60, something like that in your book. So you'll need to go through there and get those definitions in your notes today. So let's go ahead and start today's lesson. This is only my second Google video, so good luck to me, and I'm sure you will all get an amazing laugh out of it. So here we go. Okay, so let me show you what I've got going on in my screen. I have a lot going on in my screen. Okay, there we go. So example number 1, state the domain and range of the relation shown in the graph. Is the relation a function? So first things first, the domain. The domain is always going to be your x-axis, also known as your independent variable. So for this, you actually have squiggly brackets because, oh man, because it, and yeah, I have to write with my finger, so disregard how terrible it looks, but it's a set of numbers, so your squiggly brackets are back, and we're only going to do the x values of our ordered pairs, okay? So those are going to be your domain, and you do not need to repeat numbers that show up multiple times. So for our domain, I'm going to get a -2, 0, and there are 2 zeros. I only need to write it once, 1 and 2, and that would give me my domain. Domain means what x values does this take on. Range is going to be your y. Okay, so I don't know if you can see my little pointer there. Those are going to be your y's. So again, let me erase my yellow, and I will highlight your y's. Your range, those are going to be your dependent, and there you go. So for my range, and again, if it repeats itself, I only have to write it once. So for my range, I have a -4, 2, and 3. So the other part of the question was, is this a function? So the way you can tell if it's a function, for each domain that you have, each x that you have, so each x value can only have one y value. It can have multiple repetitions of the same y value, but if it has different y values, it's not going to be a function. So we run into a problem with this function here because this ordered pair right here and this ordered pair right here, they both have the x value of 0, but they have a y value of a 3 and a y value of a -4. So that creates kind of a problem for us in the fact that you can only have one y value. So this is not a function, and you have a box. I don't have it on my screen, but you're going to circle no. And the reason is because x, actually, let me get a new sheet. No, because x equals 0 has 2 y values that are different. Okay, so that is the reason why. So I can't answer questions today, guys. I'm sorry about that. So today's lesson is probably going to seem, wow, holy cow, Miss Magruder should do lessons via video all the time. But I will answer questions on this when I get back on Tuesday. So let's go ahead and pull up example number 2. This one right here. It asks us to graph the values for the relation given in the table and determine whether it represents a function. So first things first, we are going to determine if it's a function because of the vertical line test. Okay, so the first thing we need to do is we need to label our axes. So you need to tell me that this is the y-axis, this is the x-axis. You're going to want to go ahead and number, and I know my numbers are terrible. I'm drawing with my finger right now. There's 1, 2, 3, 4, and we'll do 1, 2, 3, 4, and then we're going to go ahead and graph these ordered pairs. So the very first ordered pair that I'm going to do is 0.5 and then up to 2.5. So over 0.5 and up to 2.5, and I'm going to put a dot. Oops, I forgot to change back over to my pen. I'm going to put a dot. Oops, 2.5. Okay, I'm having a hard time coloring with this pen, but there's my dot. Okay, the next ordered pair that I'm going to do is the next one here, which is 1, 3. So I'm going to go over 1 and up 3, and I'm going to put a dot. And I'm going to continue to do this until I have my entire graph on here. So 0.5, 1, and my very last point is 1.75, which is almost to 2, and then up 3.5. So right up. Aw, dang it. Right there. Okay, so there's my graph. So now to the vertical line test of our question. We went ahead and graphed the values for our relation over here. And now it wants us to determine if it's a function, and I want you to use this thing called the vertical line test. So all you're going to do is you're going to draw, or take your pen, hold it vertically. Let me see if I can actually hold this back up here so I can show you. Aha! I think, okay, so hold your pen like this, and then you're going to go from left to right across your graph, and you're going to hope that it hits only one point at a time. So let's go back to our graph. And if I take my pen and I start going across, do you notice that right here, your pencil runs over both of those points at the same time? So that fails the vertical line test. It fails the vertical line test. So this is not a function. Okay, not a function because it fails the vertical line test. Okay, so we're going to use that method a couple more times today in our notes. So let me hide this here and get on to example 3. It just simply wants us to graph the relation. Oh. It just wants us to graph the relation, and then the next part, which is on another slide, it wants us to find the domain and range. So remember, we just took a test on this, so this should be easy. Don't forget to tell me that this is the x and this is the y, and don't forget to label. Remember, you're going to get points off for that. So I'm not going to label any more of my graph today because I'm a monkey with a crayon right now. But I'm going to put my dot at my y-axis, if I can. So right there to -1, that's where I'm going to start. So there we go. My slope tells me that I should go up 3 over 1. So I'm going to go 1, 2, 3, and over 1, and I'm going to put a dot. I'm going to try and put a dot. Ah, I did it. And if I connect those, and again, I would connect this with a straight edge, but I'm drawing with my finger, that would be my line. Okay? So for B, flip your page over here on the next set of notes, it says find the domain and the range. So your domain is any x value that you could possibly get with this. So as you look across this x-axis right here, what x values could you possibly get with that line? I hope you're saying all of them. And all of them means that the domain is any of the reals. Okay? It also asks us to find the range. And the range is what values can I get for y? So as I look up and down that, are there any values that I can't get? And I hope you're looking at it and saying, no, I can get all of them. So that would be all of the reals. Okay? And finally, C asks us for determine whether the relation is a function. So go ahead and use your pencil again. Whoops. And take it, set it vertically and go left to right. And ask yourself if it hits the graph more than one spot at one time. And hopefully you're going to tell me that the answer is no. So this is a function because it passes the vertical line test. Okay? Surely your notes look way better than mine as I am a monkey with a crayon today. So let's go ahead and move on to example number 4. So example number 4 says graph the relation represented by y equals x squared plus 1. So to get your x's, the very first step that I have highlighted over here for you is you're just going to choose your x values. So all of these values right here, I just randomly chose those. Okay. I like not to kill myself, so I try to keep those nice and small. Okay, so I take those x values and I plug them into my equation. So my very first one is y equals a negative, my x now is a -2 squared plus 1. So I just have to simplify that. So a negative, and then a -2 squared is 4 plus 1. So I have y equals a -4 plus 1, which is a -3. Okay, so I got a -3 right here. I'm going to go ahead and tell your sub to pause and let you guys fill out the rest of your table. So I'm assuming she paused, and I'll go ahead and fill these back in for you. You should have gotten these values in your table. Okay, so over here in your steps, I have a tiny box, so I'm not going to be able to make it. But your second one is to plug into your equation. Okay. Your third one is that's going to give you, that gives your y values. And your fourth and final step now is you're going to graph your ordered pairs. Okay. So you're going to graph your ordered pairs. And I already graphed them for you. This is the graph that you should get when you graph your ordered pairs. Okay. Okay. So B asks you for the domain and the range. So the domain. Let's talk about that. As you look at this graph here, look at your graph. What values can x not have? Well, if this graph continues on forever, it gets bigger and bigger, right? So I'm hoping that you're telling me that any x value will work. So your domain is going to be, again, all the reals. Okay, so let's talk about the range. The range is the y-axis. Okay, so what y values can you get on? Well, notice that you don't have any y values above this right here, that apex, right? So the highest y that you could possibly get is going to be 1. Agreed? And I can't hear you guys now. So it could equal 1 or anything that's below it, also known as less than. So your range is going to be any y value less than or equal to 1. Okay? It asks for C to determine whether the relation is a function. So again, you're going to take your vertical line test. You're going to take your pen, you're going to hold it vertically to your paper, and you're going to drag it across. So this is how your pencil is oriented, and you're going to pull it this way. Do you hit more than one point at one time? Hopefully the answer is no. So yes, it is, because it passes the vertical, I'm going to call it LT since I'm running out of room. Okay, perfect. So let's look at example 5, and then hopefully you guys will not have homework this weekend. I don't know, period 4, are you guys going to have homework this weekend? I hope not. So here we go. Last thing we need to talk about is function notation. Function notation, you guys already know how to do this. This is just a fancier form, okay? So A is telling you to use F. So the equation that I want to use up here is the F. I don't care about H at all, okay? And that 2 in there is really like saying x equals -2. Okay, so what they're telling me is use the F equation, and everywhere you see an x, put a -2. So I say, okay, here's my F equation, and everywhere I see an x, I'm going to put a -2. Most common mistake is you guys want to do something over here with this. Don't do anything with that. Just leave it there. Okay? We're only going to deal with this like it's an expression. So a -2 cubed is 8 minus 3, and that gives us 5. So F of a -2 equals 5. Okay? Now I got to erase some of this to make some more room for myself. So let's do the next one. So now I'm going to do H. Oops. So again, don't freak out at this notation. It's telling me to use the formula H. Okay, well that's this one. And it's telling me in that equation, make x equal 1.6. Okay, so here we go. We say 0.03 times 1.6 squared minus 3 times 1.6 minus 2.7. Okay, and if I simplify that, I'm not going to take the time to show you guys that because you guys are all super duper stellar rock stars. You get 7.42. Okay, so h of 1.6 should give you a -7.42. Again, don't freak out. It's just a special notation. So again, I have to erase that to make some room for myself. So I'm going to erase all of this right here. I'll leave that one down there. And last but not least, we're going to do this one right here. So it's telling me to do the equation F. So that's this. And it's telling me everywhere I see x, make that equal 2t. So I start going. I say, okay, x, I'm going to make that 2t cubed minus 3. And sorry if you guys haven't written this down yet, but I have to get rid of it. So copy off of your partners. Okay, so 2t cubed gives me 8t cubed minus 3. And that I can't simplify, so that is my answer. That is f of 2t. Okay, so that's my last answer. So please be wonderful for your sub today. Like I said, I will come back and I will answer questions for this on Tuesday, but you are going to do your 2.1 homework tonight. I guess I can show you my face. So please, please, please be good for the sub today. I know 2.1 was probably rough since you couldn't ask me questions, but attempt it. Some of you might have already seen it. If you have, please help your peers, and have a wonderful weekend. And I will see you guys on Tuesday. Talk to you soon. Bye.